Okay, let's look at how to do the questions in the worksheet number 2. So firstly, we have such a question. Question 1 want us to find such a derivative. And remember that we have such a formula to find the derivative with the power. When you have a constant times x to some power, the derivative of this, I use arrow to mean that to find the derivative of it is just constant is still there. Then you move the power to the front times x to the power minus 1, okay? This is just a basic formula we often use. And if you do not know where it comes from, please review your lecture notes. So look at this question. Here, it is just 1 times x to the 5th. In other words, it is 5 times 5 minus 1 is 4. 4 is after doing the derivative, right? This one is negative 2 is still front, it's a constant in front. Negative 2 times 3 is to the upper. So you move the power front times x to the 3 minus 1, which is 2. Dot, dot, dot. You do everything similarly as this for the following terms. I should write f of x equal to. Second question, f of x e to the x. And this is just a directly applied formula. The derivative of it is just e to the x. Okay, please look in your lecture notes to see where the formulas are. How about the third one? F of x equal to e to the 6th power. Remember that natural number e is just a number 2.7-ish. So this is just really 2.7-ish to the 6th power, which is a constant. And any constant, when you're looking for its derivative, it's just to be 0. Another way to think about it, when we think about the derivative, we mean the slope of the function, right? And think about the slope here. Imagine this is a coordinates. The slope here is just the slope for this line. This line is where e to the 6 is. Obviously, the slope for this line is just 0, okay? So let's look at question 4. Question 4 wants us to find the point slope line or the tangent line at x equal to 4. The function is given, and the point also given. So what you need to do is figure out this point slope form. We talked it in today's class already. So this is a f of x value. I write y1. This is just the x value, which is 4 in this case. The slope is just a derivative. So now you need to figure out what is f of x. That is, what is f4 here? And clearly you can do it in this way. So you just plug in 3 times 4 squared minus 8 times 4 plus 4 times square root of 4 equal to a number. Then you have the f prime of x. This comes a little bit complicated. You should differentiate the function to find the derivative of it. So f prime of x, we have a polynomial again. You just apply this rule. Do very similarly for this polynomial. the power 2 move to the front, then the power 2 minus 1, which is 1, then 8 times x. It just turns out to be 8. Then you have 4 to the square root of x. In other words, it's 4 times x to the 1/2. You can move the 1/2 front. So it turns out 4 times 1/2 times x to the, this power minus 1 is minus 1/2. So what do you get? You get 6x minus 8 times 2 times x to the negative 1/2. Okay, that's your derivative function. Once you figure out this, you need to figure out what is f prime of 4. That is easy. Just plug in 4 every time you see x. So be careful. Remember to recheck your solution again and again. You can double check with other students. You can also check by yourself again and again. Make sure you use the right number, okay? That's question 1 to 4. I'm going to make another video to talk the following questions. Okay, let's look at question 5. Question 5, you are given with a line in such a shape. The question asks you to mark where it is the function is positive and where the function is negative. Look at the curve. Obviously, this line goes below 0 when it is here, when it is here, here, okay? And it is positive when it is here, here. So you have to write down the intervals like this, those intervals. In our case, where it is smaller than 0, you see it's here. So how do you write this point? It is negative infinity to negative 4. And don't forget to also have this piece. This is from negative 1 to 3. Notice that we were asking about strictly greater than 0 or smaller than 0. So you have to use parentheses, which means the endpoint are not included. Okay, the endpoint gives you 0. So they do not satisfy this. So they are not included. Don't forget you should write a union sign. And where they're greater than 0, let's look at this graph. It is where these pieces are. What are those pieces? Those pieces from negative 4 to negative 1. So for greater than 0, you can write negative 4 to negative 1, and also this piece. This point is 3. So starting around 3 to everything on the right side. Union 3 to positive infinity. That's where it is greater than 0. Question C and D ask you where the derivative is. Notice that derivative only care whether the function is increasing, decreasing, or level out. If it is increasing, it is positive. If it is decreasing, it is negative. If it levels out, it's 0. That's it. So go back, look at this graph again. Obviously, here it levels out. So here it is 0. And this piece is increasing. So everything on this side is positive. This piece is decreasing. So negative, again, increasing on this piece. Everything on this side is positive. So you can just write the interval from here to here is increasing, which gives you negative infinity to -3, this piece, okay? This corresponds to -3. Then you start from here, positive 1 to positive infinity. This part is increasing. I didn't write where it is decreasing, and I think you, by right now, you should be able to figure out what is the interval from here to here. Okay, the last question, question 6, is the most tricky question on this worksheet. We all learned this formula. The last question, we want to use this formula to finish some calculation trick, to find some limit easily. Let's say if you have such a limit, it looks very messy and we do not know how to do it directly. Those x minus 1 cannot be canceled out easily. So how do we do it? Again, we notice that this is just a function, right? Function minus 1. And this 1 just f of a in our rule here. So this is just f of x here, and this is x minus 1, which is x minus a in our rule here. So this just fall into the category of this. And the answer is that the limit of this just equal to the derivative at that point, okay? The function is this, the derivative is this, and I use a vertical line to denote the behavior that we are going to evaluate the value at x equal to 1. So taking the derivative of this function, which is just use the power rule, move the power in front, original power minus 1, 39. And notice that x here, you should plug in 1 because our x is 1. So just plug in 1, 4 times 1, just 40. That's it. So this is just a toy example. Here, the question asks you to find something more difficult. Again, we use this formula. Look at this formula. A function minus something, x minus a number, okay? So we notice that this is still in the rule of a, placed as a here. So this part is still the function. So our function is f of x is x to the 4th minus 10x. At this point, 3, what it is, f of 3 is 81 minus 40, which is 51, exactly here. So this is our f of a, this is our f of x, this is our x minus a. So this fall into this category exactly. We can use the same way to solve this problem. This limit, in other words, is just equal to that derivative. So what is the derivative here? F prime of a, and we figure out a is just 3. So it is just f prime of 3. Then your leftover job is just calculating what is f prime of 3. Before you do that, you need to know what is the f of x, okay? And here f of x is x to the power of 4 minus 10x, and f prime of x, you can just use this f of x to find the derivative, which should be very easy. Just apply the power rule as you did for previous questions. Then plug into 3, you get the number, okay? That's it. So make sure you understand the basic ideas behind the question. Then all other jobs is just plug in the numbers, do the correct calculation. You can double check with the classmates, make sure you write everything right. Good luck.